essentially what we're imagining is pick up, the hey Malcolm, I'm telling them about everything that's happening. So pick up an API server's HTTP API / v1 / namespace, like all the way down the structure of an API server's HTTP API, and stick a prefix intent on it, and that will exist in a Grafana instance. And we want the interactions to be essentially the same. We want it to be a schema-driven thing where you can send in, here's my custom resource definition. You can potentially attach an operator to do things. Grafana is not going to become Kubernetes. It's not going to become a scheduler. So we're going to, rip out pods, deployments, most of the actual business domain logic of Kubernetes. Essentially the same thing as what KCP has already done.
I was just about to say, is what Clayton are working on?
There are, we've already looked at it. It's not in the shape that we can directly use as is at the moment, but it's okay. We'll make those trains converge at some point. Because the point is, Grafana's got a bunch of config objects. These are fundamentally things that we could express via schema. We've got a fair bit of mess when it comes to our existing storage. There's things that we don't need to be doing. It's more complex than it has to. You still have to sort of manually wire up HTTP endpoints and your CRUD logic when you create new object. This stuff shouldn't need to exist. And we can take care of most of it, albeit on the other side of a fair bit of refactor, by saying, let's use Kubernetes object model. Couple other things though, because what this really unlocks for us, and the way this connects back to Poly, right? So the way that we're talking about this is we'll have our Kubernetes shaped API under intent, and then everything else stays in place. This is, if nothing else, just a strategy to be able to do things incrementally, right? We can't blow up all existing Grafana users. It has to be something we do over time. We don't want to refactor everything in order to get any value at all, yada, yada.
Just as you can add, also the largest user of the existing API is the front end. Screw with the API that we currently have, and you've got to rewrite the front end, not going there in a hurry.
Yep. Yeah. We'll get there nice and incrementally. The thing we can do, and the way that the neat little thing that Kubernetes really hooks in with here. All right, I'm going to draw some things. See if I can do this better than last time I did it. This whole business. Good. All right, so if we have Grafana, and basically a Kubernetes shaped space. So running Grafana instance, we have our existing HTTP API, H there, whatever, whatever we can take requests here to our HTTP API. One of the big issues that certainly Malcolm, but essentially anybody trying to write a tool to provision Grafana has run into is that this is awkward as fuck. It's really not designed to take objects effectively from the outside. Part of this has to do with simply the sort of sprawling way that dashboards work, and the fact that you embed multiple objects inside them. It has to do with juggling IDs. There's a number of things. Let's not go into them. But the sort of key is that we have to not come in the front door if we want to make a system that can provision Grafana effectively. And the problem is we have to figure out how to make a backdoor because we can't change the front door without fucking up the front end, as Malcolm points out, right? So how do we do it? So if this is our existing, let's call it, this is classic API, right? Then we have our sidecar API down here with intent. So the idea is all of our classic Grafana stuff is happening up here. Nothing has really changed. But we have our intent API, which again just prefixes intent / and then it's an API server. Okay, so we'll tell our avoid talking about mechanics at least for the moment, but we tell our thing that builds our intent API that, like, here's the schema for dashboards, right? So that ends up creating the set of endpoints associated with manipulating a dashboard, putting them, getting them, whatever else. Cool. So if you then, the nice thing about doing that is that because we're not actually messing with the classic API, we can have a slightly different dashboard spec that shows up there, specifically like the schema that we have been working on that we import in Poly, right? Like thus far, those two things are more or less aligned, but there's going to be like a point where they sort of diverge in the woods, perhaps. So if you write a dashboard into the intent API in the same way that we would, want, in the same way that it would happen in Kubernetes world, there's a controller sitting somewhere actually inside the Grafana process, crucially, so this whatever, comes in and, oh God, this is turning out worse than my previous ones. This ends up in special like intent storage, etcd or whatever, so Kubernetes shape, right? But the dashboard controller, as you would with any other controller, sees the object right come in and then can reach behind. It goes through the back door because we're already inside of the Grafana process to be able to write directly into classic storage and make Grafana continue to operate the way that we want it to. So we are grafting on, God, that is a horrifying set of arrows. Oh God, it's terrible, I'm sorry. But we are grafting on this additional sub intent API that lets us basically get controllers that run inside of the Grafana process, bypass the front door, still allow everything to sort of work as they do, but we can craft the workflow that we want for actually like working with objects. And of course, because it is Kubernetes, it's all very nicely extensible. Initially, while we do eventually have to have this be embedded, initially we're just going to delegate off to an actual like Kubernetes API server. A bunch of chatter back and forth. Like Grafana has to be an operator that registers with that Kubernetes server in order to get notifications that objects have come in, and trigger all these controllers from the inside. But that's the essence of our loop. But
just a question: is the you've got the intent store there? Isn't that actually part of the API server itself?
Yes, it is. That's why I'm moving it over right now.
Okay, good.
So this is effectively on like the Kubernetes side. We can call this intent store, which is
etcd or whatever.
etcd or whatever, right? So yeah, I mean, we have a bunch of work to do. This is also going to be an excuse for doing a bunch of like the refactoring that really needs to happen within Grafana. But once we have this in place, once we have our little backdoor for being able to like get objects in effectively, and we have Kubernetes style CRDs and controllers that we can do things with, then fun things start happening. Whatever we have, like we have a CTLR. We have a controller that the API server is talking back to, and then brokering connections off to lots of other controllers for each individual Grafana object type, so that we can like write them back into classic storage. Once we have that, though, that's when we can start layering. So the simplest way I think to imagine it is we can easily imagine having, let's call it a poly operator which is doing operator things with the API server. Register a CRD that says this is what a poly package looks like, and is able to do, I would imagine, because I have not actually spent a ton of time with the operators that we have, but able to do at least some of the things, same kinds of things that we have done in existing mixin based operators, where taking a mixin, like expand it out to
So
write
you
a
get
dashboard, for example. Go ahead.
you get interesting things that I haven't really thought about. But so effectively, where it says D going into I on the left, instead of passing a dashboard into the intents API, you could pass a poly package into the intents API. That will be pushed into the Kubernetes API. The dashboard controller will say, I don't know anything about that. It'll ignore it. It's just nothing to do with it. The poly operator will then act like a deployment operator in Kubernetes and say, I know this thing. I will go and create some pods, but they're not pods, they're dashboards and alert rules and so on. Put them back into the API server, at which point the dashboard controller and the alert rule controller, etc., and I say, oh, look, there's things I'm responsible for. It goes and pulls them over and pushes them back into the upwards bit in the diagram.
I do have one question about it. Sorry, Michael. What about changes from the front end? Like if I do changes on the front end, how they are going into the system?
Yeah, I spent 2 days working out all the sequence diagrams to explain that one last week. So it's almost, it took a while for me to get to this because I think it's really important, really, really important that we have one flow for like all of what follows. So I'm going to start from, I'm going to start with the most basic thing, right? Like anything that comes in through the intent API, the object that ends up here is immutable to the front end. That's the baseline that we start from. This is what Grafana should have done in the first place with all of its provisioning. If you provision through intent, it's immutable because you provisioned it externally. It shouldn't be editable in that Grafana. Very simple baseline answer.
Sorry to chime into that. So with that assumption, you're essentially doing what we already have, kind of, because Grafana already has a provisioning API via files inside the pod, and everything else that you're adding here is basically what we have in Kubernetes and doing via config map. This is basically how Prometheus is working, because we are just locking the whole thing as an immutable Grafana instance and just shipping it this way. So what's the difference?
So I mean, like, this is correct. It is a good model. The problem is resolving that tension, because indeed you do need to make edits from the UI. So the thing that changes when we introduce the system of intents in a way that makes it a formal part of Grafana's own UI is it allows us to create write-back paths in a structured way. Like I said, the normal case and the important thing to start from is if it's written up here, it's unwritable by the UI because this is an externally provisioned object. However, once we have settled on the idea that like we have an intent API, we have an intent storage, and that is a part of Grafana, and therefore the Grafana front end can be taught that it exists, then we can come up with standards around the metadata that we keep on objects to know about their provenance and attach special writability rules to them based on whether basically the set of controllers that we have knows how to initiate a write-back operation. So for a GitOps case, it would be basically like a pull request workflow, right? Like, is the thing, I haven't pictured it here, but let's say that you had a like Flux's Git source controller that like exists today, right? So Git source mapper, right? So if that's doing the thing where it's reading things out of your Git repository, sending them the Kubernetes API, which then gets sent over here and picked up by the dashboard controller and synced into classic storage. The key thing is adding just enough metadata onto that dashboard as it passes through the system so that we know, the front end can know that it came from a source mapper. We can then first check to make sure that that source mapper is capable of doing write back at all, which not all of them will be, and that's fine. And second, that the user actually has like permission to do so. If they do, then we have a system with like, it's a whole like I like literally have sequence diagrams because it's the simplest way to explain it. I have a system that I've worked out for essentially maintaining local derivatives of upstream external objects that can be in the indeterminate state, like while they are being reconciled back with the upstream, aka while the PR is in flight. We have a way of keeping the object locally so that you can push things back out to the original source if the source supports it.
So you're essentially baking in the Grafana operator into Grafana itself and merging it with how secrets are handled in Kubernetes 121, I think, because you can set an immutable field for a secret, and even Kate's API cannot modify that, which means that is parallel to how you are saying what you are saying about dashboards, because to Grafana, dashboards through that intent API is also immutable, which is the same for secrets in Kubernetes with an immutable field set to true.
No, because in this sense, a dashboard uploaded to the intents API is mutable. You can change it. The one within Grafana itself is immutable because you can't change it from the UI. In order to change it, you have to do it through the mutable intents API.
So you basically need to delete and recreate that.
No, I mean, like, dashboard comes in from the Git source manager. It writes a dashboard object to the API. That one is mutable, at least by the source manager. Perhaps RBAC indicates that only the source manager is allowed to write that object, but it's still writing new versions of the object. It's literally doing patch whatever or new put versions, and the metadata generation number is bumping up as new ones come in. But the way that we implement the Grafana front end is that it is not allowed to write anything that under no circumstance will the Grafana front end allow you to write or render a UI that suggests something is writable unless,
I completely get it. I have zero view on that, how that helps anyone, apart from in the long term. I don't see anything how it helps users right now, because users can do exactly the same thing without the intent API. Because right now you can do intent with just putting a config map through a provisioning API in Grafana, and it will be picked up. And if you do Grafana that is stateless, you don't have a storage for that, and you cannot modify that either way. Mm-hmm. So if I don't have a write back to that through the API, through Grafana frontend, I don't really see how that has any benefit.
No. So the write back is absolutely crucial to it. But I think what Sam's saying is that the baseline is it's immutable. You can't change it unless, and the unless is the key thing, unless the controller behind it. The dashboard in Grafana will be recorded with, I came in through this particular controller, and it will go back and check, or this particular source controller, and it will can then check, does that source controller have write permissions? Oh, it does. Right, it's now writable. And imagine this scenario: you push a poly package, or rather, the Git SM notices a poly package in a Git repository. It pulls it into the API. The poly operator notices that poly package, decomposes it into dashboards, annotates those resources saying it owns them, pushes them into the API server. Now, there's dashboards in the API server. The dashboard controller says, oh, look, there's dashboards. I know what to do with those. It picks them up and puts them into Grafana. Now, someone edits one of those dashboards because they have the correct editor permissions and so on. They click save. That dashboard now gets pushed back into the API. The dashboard controller picks that change up, pushes it into the API. The poly operator says, the Git source manager says, I don't know anything about those things. They're annotated in a way that says don't touch them. The poly operator says, oh yeah, I know those. I created those dashboards. Oh, look, it's changed. Hang on. And it now updates its poly package and then puts that back into the API, at which point the Git source manager says, oh, I know about poly packages, and pulls it and writes it back to Git. And it's like, holy shit, did all of that actually work?
Yeah,
I sort of decomposed, yeah.
I'm smiling right now because I have a whole power of Kubernetes behind the systems I'm looking after.
Yeah.
And quite a lot of that stuff is just figured out in Kubernetes. Right. I can completely understand that Grafana has to look outside of the Kubernetes world. But for me, it's like, oh yeah, this is a config map. This is basically a dashboard. I just provision this here, and I have a controller outside of the Grafana pod.
But that's essentially what we're saying. Is that like there are key things that have been figured out in Kubernetes. We're going to take advantage of them, and we can use them to facilitate this. The write back case is for Grafana in general, independent of poly. It's extremely important. Like the thing that I always think about is how at Stripe, like we had a system for doing dashboards and code. 90% of people did not use it, and I was never actually certain whether, and I mean, like literally, we did the counts to see which teams were using the Terraform-based system that we used. 90% of people did not use it, and like, I also wasn't ever actually sure whether the objects that had been provisioned had not been modified in place, because the natural place to do this work, as we've talked about lots of times, like is in the UI, right? So having a generic mechanism that allows us to do a write back path, whether the target is going back to a Git source manager, or if we have something that's talking to like a poly registry, I want to install this poly package. Cool. Okay. If you have, credentials to be able to publish to the poly registry, cool. Then this can be your instance in which the maintainer of this poly package, like edits the poly package, then publishes it back to the registry, and then it flows out to everyone else who is paying attention to the registry. But having a generic system for being able to do the local edits on externally managed objects lets us facilitate all the workflows that we might want to have where, we want to sort of use the Grafana as an IDE. Being able to do this then also lets us do simple things like, well, I don't know. Yeah.
Can I just add one thing? Just to speak to what Pavel's saying. In a way, what you're saying is kind of, isn't this obvious?
Kind of.
Yes. Yeah. No, it is. That's the point.
And actually, that is the point. But what we're doing here is, what in a way, kind of what's leading us here is like, we are a Kubernetes shop. We use Kubernetes for everything, and we've used Prometheus, KSonnet, and so on to see the power of deploying your observability stuff through these techniques, and we've loved it. But the problem is, the world isn't a Kubernetes shop. So we're kind of stuck in terms of providing Grafana as a thing to the world. We can't just say, oh, just use Kubernetes, because people don't. So what we're looking at here is how can we make the power of Kubernetes available to every single Grafana user, regardless of whether they use Kubernetes or not, which may not be relevant to you because you are a Kubernetes user, in which case, but the key thing though is actually, how do we get to the case where we offer all of this power to your Kubernetes users and your non-Kubernetes users? Well, we've got a lot to learn, so let's start just by focusing on the Kubernetes users, and we'll solve the problem of providing Kubernetes functionality like KCP, etc., embedded in Grafana or whatever it is at some later point in time, once we've ironed out all the questions of actually, what are our CRDs going to be? Are they going to be CRDs? There's lots of details, writing these controllers and operators and so on, how we orchestrate all of those, whose job it is to push them into Kubernetes, where those operators actually run, we'll just be, I think as Sam tends to, waving hands at that point. We can just use Tanker to deploy them for now and defer that problem.
One high-level question in the way that the narration currently stands on Sam's whiteboard, it on a high level seems to me that you're saying, oh, you need Kubernetes for that.
No,
you need to have an existing Kubernetes
not.
cluster. And
Yeah,
that is when you started explaining. It's like, oh yeah, well, that's cool. I can have a native way to run.
Logistically speaking, we started by looking at KCP, and I think this is key to note, especially given what Malcolm was just saying, right? Like, we are not. I think it is fair to say that we will be making Grafana way more cloud native with this approach, but we are not going to be marrying it to Kubernetes specifically, in that we at runtime eventually do not actually want to rely on an external Kubernetes server. It will be embedded. We cannot make this like a standard thing that's available in all of OSS. If you have to also spin up a Kubernetes server in order to literally run your Grafana instance, that'd be nuts. So we can depend on an external one for now as we prototype. It's something that obviously we'd be able to make use of in our cloud offering because we've got Kubernetes all over the place. But and we can build our API around it. But we can do sort of all the things. But I'm not sure how long it will take to get KCP mature enough, or if we roll our own to actually embed it inside of the OSS product. The point is we don't have to wait for that in order to start moving. And we can,
Another a bit tongue-in-cheek comment. It's probably already too late. You already have done your homework, but in case you need to upskill others, there's a little book that Stefan and I have written that may be useful to communicate specifically. The last couple of chapters may be useful. Maybe there's something in there that
honestly, I think that is, as far as I'm concerned, the go-to book for the topic. So it's already been mentioned to me by colleagues. So
from what I take from Sam, they have already figured out everything and whatever, but it might be useful.
We have things to figure out.
we're working out operators, getting ourselves fully tooled up to make operators, knowing all the issues around that. No, I think you're right. We should read your book.
No, that wasn't the point. The point was more like there's a if you look at all the channels and all the other things that have been published so far, this is more like the baseline, but there are a number of and Pavel definitely has much more experience than I in terms of from the operation point of view, right? But there are a number of things that come to mind. If I, for example, think of the current way where the authentication goes, right, with the fine-grained permissions, etc. And then if you have RBAC natively or can leverage RBAC, the Kubernetes RBAC, right? Those are areas where I buy all the other things, right? But those are you really want to think through all of that, right? Mm-hmm. All these baked-in assumptions and everything that the Kubernetes concurrency, right? Like optimistic concurrency, right? At its core, right? Is that something you take one, or are you limiting it? Are you kind of streamlining things? I like very much the way Malcolm described it with the different custom controllers playing together and in an idle world that works. I'm just thinking of this is a UI, right? This is like something where I click on something and what is it, 10, 30 milliseconds, whatever the barriers where human user starts to notice, that needs to reconcile damn fast, right? You really cannot afford a second or two reconciliation loops.
This is part of the reason why I mean, depending on what you're doing in the UI, are you talking about getting a response time when you change something, or
coming back to what Pavel said in the sense of from an end, imagine all I'm just using it, right? I may or may not know about Kubernetes or whatever. I'm just using it. I have a baseline in the sense of I know when I click on, I don't know, whatever that save button is, change something in the dashboard and say save, right? New version, I can enter a comment. And I have a feeling for how long that takes, right? Imagine that now doubles. Like I would probably think there's something wrong, right?
So this is it's it's funny because having had a few versions of this conversation, like I agree. The design of the local object system to support like write back is essential. A lot of ways that it could go wrong. What I have laid out in the documents I've written so far, which you got to figure out how and where to share, but is that none of this works unless we design all local object concepts to be like special exceptions from the UI forward. Like you don't, edit a dashboard that is going to ultimately go back to a Git PR and like then hit save and have any kind of visual loop where the user thinks that they're like, oh, cool, I have the most recent version of the dashboard now, the one that I just saved. No, that shift that you just made is like it's off in a side channel. It's clearly visually marked that this is something which is pending reconciliation. If you refresh the page for the dashboard that you just saved, you're going to go back to the one that is like the canonical upstream one, and then there's a little toggle somewhere to go find the local version that you just saved that's currently pending reconciliation. We have classic storage and we'll continue to have classic storage, and this is the normal way that Grafana interacts with stuff because we do not want the UI to get caught in reconciliation loops or assume that it's something. Really what I'm trying to say is there's a whole lot of weird distributed system shit that can happen when you're trying to push those objects back, which is why the entire system is designed around the idea that that's an async process. And we will keep track of the fact that the async process exists, but we will never alter normal UI behavior in order to use something that like may or may not be synchronized. The user has to explicitly opt into like seeing stuff that's in the weird gray space, perhaps before it's been reconciled. So there's a bunch of details that go into that. But the thing I was hoping to, in running through this description here, is to talk about that, because one of the things that the poly operator, like what I've been stuck on for months in a sense, is like without having a clear sense of where poly objects would be created from and or how they would be like mapped back into running systems, it was really difficult to think about which, for me at least, who needs to see the finish line before I start something. It was really difficult for me to think about like how to craft poly packages such that they would fit well in this in a deployment model. Like it was fine to talk about we could do a dumb CLI thing, but like everything we started running into as soon as we talked about dumb CLI things was all of the bullshit with like Grafana's HTTP API. So what should we do now that we can bypass that and we can really just say like the schemas that we have written are going to be sufficient expressions of these objects. I feel like it's easier to actually talk about a poly operator, which, to be clear, like at the very least, a poly operator that like reads from whatever OCI registry we end up being able to write these things to. Like that is something that I expect, at least at some point, we will have Grafana Labs internal people working on, and that will be open source. It'll be Apache 2. I see no reason that it wouldn't. So like, what would that? I think the first iteration of this operator has to like not allow variable interpolation, but I'm curious about, Pavel, what you think such an operator would be shaped like.
I don't have like out of right now any idea on how that would how that would be shaped like. However, even looking at that graph you wrote at the whiteboard, it's clear to me that this is basically the operator that is creating CRDs from somewhere and putting into the Kubernetes. And that's actually how you even wrote it on the whiteboard, because that operator is essentially interacting with the Kubernetes API, which means that it's interacting via a CRD, which means we are getting back to discussions from like February or something, that everything in poly package should be basically a CRD. And we are kind of getting into the same area that Prometheus operator is working with. But you have a Prometheus rule CRD that is injected into Kubernetes, and the operator is taking care of that and transforming into the Prometheus configuration. However, with the configuration that Grafana can connect directly to Kubernetes API and do its magic, it's even simpler, because you don't really need an operator at that point, because that thing can be external completely, because you are just applying CRDs, which essentially means that you need kubectl.
Yeah, I mean, there are a couple things. There are at least a couple different roles, right? Like something that is able to, if we're just talking about like a set of objects that need to be unpacked out of a package and dropped into place, then yes, we don't have. There's very little for an operator to do. It's there's not much point to it, I would imagine. Good to hear you confirm that at least. I think there are a couple other things though. Like one is, if we have an OCI registry, then there is at least some operator which is going to be introducing a CRD that says that expresses the user's intent to install a poly package at a particular version, which is a higher order consideration here, right? Like that introduces that CRD, and then it's easy to imagine making a UI for, that you can pull up in Grafana and, hey, here's the available poly packages. Here we're going to run some of the queries in the context of your available data to do all the sort of testing and see which ones are appropriate or perhaps applicable to your environment. Like that's at least one additional role. Go ahead, Malcolm.
And you're saying there that you have a CRD, which is a remote poly package, and into that you specify, here's the URL for the poly package, here's its version number, and here's the 5 variables that someone's entered into the UI that's going to be inserted into that poly package for a parameterized one. Assuming that's
I'm separating variables for the moment, because I was going to talk about that next. But
then what that poly operator would notice a poly reference, resolve that into an actual poly package, which then the whole process kicks off.
This looks like a Helm chart.
It does. That's the thing. Of course it does, because we've been in the same problem space from the beginning. The main difference has to do with like which things you actually write down, and whether, the main difference with Helm actually is that there is a opaque barrier between what is written in the Helm chart and then like the objects that appear on the other side, the config maps or whatever thing you're actually trying to map to. Each Helm chart creates its own little universe of values that you're allowed to specify, whereas what we have here is much more transparent pass-through, and that difference is significant.
Yeah, I'm just I was referring to a Helm chart because this is basically you're taking one CRD, which is specification for a poly package with variables and whatever, which is basically Helm values, and putting that through operator or controller or whatnot, and getting a CRD that is a definition for dashboard or recording rules or whatnot. So basically, this is something that is literally doing, if you don't have an interaction in the other way, so like any other interaction, this is basically a CLI tool wrapped up into a container and put it into a cluster.
I'm sure there is a Helm chart operator or something.
Of course, of course there is. Red Hat wrote it, so
okay. Right. Yeah. Well, but again, yes, no. This is what we're doing. That should be what we're doing. That is the problem space that we're in, right? I will sharply differ, however, on whether it's the same as CLI, because the provenance chain and where something actually like came from is crucial if we're talking about making a system that is updatable. Like, it's the UI driven choices again, right?
No, it's not. It's at that point, it's not. The operator is interacting not with the UI, it's interacting with the API. So if it's changing via UI and it needs to be changed in the API, which means the operator is only watching for the changes through the API, and it doesn't matter how it watches. If you write a watcher and list watcher and attach it to Kubernetes API, you will have instant reaction. The only change here is that the CLI won't have that watcher at the same time, which means that is the only part that you actually need for the operator at that time, because you are essentially building a pipeline that is taking one CRD, converting that into another CRD by taking information from some other source, which is basically our OCI registry. The matter is how fast that changes are applied and when are they applied. In case of CLI, that is applied when user wants it to be applied. In case of the operator, that is done automatically by using watcher from the API. So that doesn't change much, in my opinion.
I think the thing that I was trying to point to, I hear what you're saying. I think the thing I was trying to point to is it's perhaps less critical there, but like the thing that has always made data different is like whether it is sufficient to mediate user decisions just with like text interface, or if you need to actually give them data in order for them to make good decisions, right? So yes, if we're talking about a resource that represents the intent to use a poly package at a particular version, it does not matter whether that resource is created by a CLI interaction or like a user UI click. You literally will end up with the same thing. The difference between them, however, is that the user doing each of those things, we can know that the user who is operating from the UI has been equipped with whatever knowledge of how like the choice that they're making interacts with the data that they have in their infrastructure. And perhaps the person running the CLI command has some out of band way of getting that knowledge of whether this is a good idea or not. But that's the connection we're trying to draw there. Mechanically, though, no, it does not matter at the level of like that kind of expression of intent.
But you're talking here about creation of a package. I'm talking about application of a package. We're talking about.
No, I was talking about application of a package. Like I was talking about, like I want to pick a Grafana UI that we're going to use poly package X at version 14. So that's application of a package, right?
Yeah.
Yeah.
But right. That's literally creating a CRD object, a CR object that would be picked up by the operator and created dashboards from that part.
Yes,
this is the same. This is the same as you would do from the CLI.
It is. I agree. The difference is not in the object that is created. The difference is in the knowledge and the mind of the person creating it.
Yeah, but I'm talking about like how do we create that, and even if that is actually possible for a minimal viable product, because at that point we are literally creating a CLI and we can enhance it by creating a watcher for the API.
Oh yeah,
because we don't care about what is the data or how it is written to that API. Because for me, the poly package, it's exactly that. That is the package for with the data. I don't care how it is created at that point. I just need to know what is the spec for that and some examples. And later, how to apply it to a cluster, and if I need an operator to actually run it, and how that would go into Grafana, because I kind of know how this would go into Prometheus because I run Prometheus operator, but how it can go into Grafana.
Right. Yeah. No. And yes. Sorry. Totally agreed at that level. Right. And I don't know. Feels like we could go in circles on agreement about how. Fuck all that. Okay. Yes, I agree. The next thing that I was going to say though does have to do with indeed the variables bit, which I think. Well, again, we can imagine it as the thing that's in my mind is there is a significant difference between like a parameterized and unparameterized package, right? And to the point where, oh shit, this was way clearer in my mind before I started trying to talk through it. Okay. The models that we have right now for parameter passing, right? Like the Helm models, let's peel the Helm or the CNAP, right? They are all those pass in a set of, like, you explicitly pair a set of parameters with with the template, whatever, the package, and the result is an instance of the package that actually ends up going out into your infrastructure, right? Typically, the way that this is all worked is that the decision about that pairing, the creation of that joint object, is one that you have to do, like, out in your, I mean, somewhere in your like deployment pipeline, effectively. So your decision to create it, I'm wondering if, because we have a model where we do not have to expose explicit parameters, but instead can rely on defaults and/or unification to produce objects that we can not necessarily instead of, but perhaps just in addition to. Think about a model where basically imagine that, like, there's you have a tree of config, a Hira type thing, right? You know, that has all of your values you want to pass in, and that there's like a, I don't know, I have to put a second P in front. There's, am I visible still? Yes. Okay. It's like a parameterized poly, so parameterized observability. But a p-poly operator, which, in addition to knowing, sort of being a superset of functionality of the poly operator, where it also knows how to interact with your config tree, so that you can directly push changes to the config tree and have them flow through to all of the poly packages that are affected by it. This is taking something that has previously been totally in the infra layer and pushing it out to I mean, again, my main goal here would be, like, I would love to be able to know from this UI driven change the number of dashboards that are impacted, be able to preview it. It's just more data driven decision making in the UI. Maybe it's nuts.
That's kind of what I was going for with the first CRD that has an intent to install a package, because that is the same what basically Helm does. You have an intent, which is repository, and you have values, which is basically what we need to parameterize a package.
I think I think one of the things we haven't yet fully addressed or thought through is that that basically a config object is just a map string interface. It's just a tree of objects, and a lot of what Poly does is uses Q as a means to create more sophisticated things.
Right.
But you can't map a complex Q object onto a map string interface. So I don't know if Sam's maybe thought about that, but I haven't heard any thoughts yet or had many on that, other than if you were to just have a data element in a Kubernetes object and just dump the Q in there, then you can just use it as a string. But you know, there's probably better ways to do it than that.
Yeah, I'm still smiling because when we had like a first meeting about Poly, it was February or March, I was saying exactly that. User needs an YAML interface to interact and parameterize a package. A simple YAML interface, which is basically a map string. And we need that.
I have suggested before that actually, if you look at Q, Q is just it's just most of Q, or what you see on the surface is a Q syntax that represents an object model. There is no reason why we couldn't have. There is probably plenty of reasons why we shouldn't have, but there is no reasons why we couldn't have a YAML representation of that Q underlying Q object model. Now, if you're going to do something sophisticated, then you probably really, really, really don't want to do that. But if all you want to do is to insert one or two elements into a otherwise plain static YAML, then having an element that begins with Q colon or something like that says, actually, this is not going to be a static string. It's going to be a Q object that has a default value of this and can be overridden. Maybe that, I don't know, it's unsolved problem.
Yeah, it's like we're trying to do something that JSONnet is actually good at.
Yeah, no, this is one thing that it is good at, right? Is just doing this. Well, at the very least,
well,
it can pass values into positions. That's fine, right?
Yeah.
I think the thing that is, so one of the cases that I certainly imagine being an issue, and I've heard brought up in various ways, is the desire to if you're talking about trying to exert uniformity over your organization's use of certainly dashboards, but really any set of objects. These are policy objects, right? Like you're expressing constraints over what values are permissible, which are ordinarily freer in the general case. So when I think about what I would like to see, when I think about the thing that I'm trying to go after with something at this level, it's mostly about being able to push back up to, again, like the locus of user decision making. Like a constraint exists. Here is your policy tree. That has all the rules about the way your dashboards are supposed to be shaped. Something like that. So that both sets default values when you start to go to create a new dashboard, and potentially rejects dashboards from going through a save operation at all. Maybe that's not that valuable, because presumably if you're doing like a GitOps thing, that ends up getting validated when you're actually in your PR workflow. I don't know, but there is the essential difference to what I was imagining, Pablo, versus what you were describing, is that I'm saying that the joint object, the one that describes the intent to install, does not have fixed values at the time, like in the object itself. That the fixed values are computed more on the fly, like lazily, effectively. We've expressed our intent to install this thing, but when we add a new cluster, for example, we don't have to actually provision a new instance of the package that has a bunch of new values in it. That exists. And then something further downstream that is doing the explode of all of the objects in the poly package to produce the appropriate set of Prometheus alerts. That thing sees the existence of a new variable that represents the new cluster that was spun up, and goes back through and reevaluates the poly packages that are already installed to produce a new set of compiled objects on the other side. Spit out this additional bunch of Prometheus rules and alerts because we're parameterized in a particular way. Does that make sense as a distinction?
Yeah, but that makes quite a lot of sense, at least to me. And I think there will be a bit of issues with that, because you need to have a lot of logic to watch for those changes.
Yeah, there's lots of things that I think might make it shitty. Fortunately, this is all so far away. Go ahead.
One small question, because we only have 2 minutes left. In terms of overall timeline, I know this is a little bit stepping back now from the the dirty details, but if you look at what you currently are internally discussing, all the feedback from the community, like here and others, what do you think in terms of when roughly this will happen, and what is the probability that it will or will not happen? These two questions make sense.
Yeah, they do. So internally, we are talking about, I have people that I am working on getting a prototype like the really basic interaction right now. So we're already started on the process of actually like putting together a proof of concept that introduces our intent API and the basic Kubernetes interactions. Everything else flows out of that. So I think that that's the only real question, like in terms of whether it happens or not, is if we run into something like so prohibitive that we can't. We decide that we don't want to go this path at all, or that or that like we have to make such dramatic changes to the Kubernetes API that it just that a whole bunch of like assumptions not pictured here end up blowing it up. That seems really unlikely. So I'm gonna go with like we're gonna get there somehow. The question is more when. If the way that I think we can do this internally pans out, I think we could have a proof of concept version of this, like feature flagged, and you got to stick a config thing in the right place. End of the year, December. Like this does not currently seem far away from where we are, though there's still unknowns. So once the baseline is in place, we can have a bunch of different conversations at once. It doesn't matter what order we talk about, like doing GitOps versus polyoperator, whatever, and it's all of them become possible.
Is it fair to say you are POCing it, and unless there is something this POC turns up something really nasty, something like a one-way door, as we would call it, that you would not want to cross, then you go ahead with that and actually.
Yeah.
Okay, cool. No, that's cool.
Yeah. Like the longer timeline on it is that, as I noted before, right? Like we can't actually put this thing in OSS until we're able to do all of this process. Right.
That's all fine. That's all.
Yeah.
All fair and fine. I'm just trying to figure out the overall timeline and commitment there.
Yeah.
All right. I have to jump, but
okay.
Yeah, that's super interesting and super exciting. Yeah.
I'm just happy to know that like this is the thing that we can target essentially, right? Like we can talk about a CLI, like you just ship the poly package into this CRD style, and that it's going to resolve a lot of questions, I think, if we can take that approach. So yeah.
All right. Thank you so much,
Brad.
Have a good one.
Thanks. You too.
Bye now.